Hello students, so welcome to this session. So today I am with one more question to you, and this is from IBMYP Physics Grade 10, and this question is from the chapter Light, and this is a Criterion A question. I feel that Criterion A is the toughest part of all the criterion for the MYP students, and there are many reasons why it is. The reason is it's a pure application, and you have to apply the things in the formula properly, and to apply the concept in that formula properly, it is a big skill that requires and that comes only with a lot of practice. So let us go into this question and let's try to understand what are the formulas involved and how you apply that here. So moving forward, a diver at a depth of 4 meters notices an unusual behavior of a sunlight underwater. Some rays behind some rays bend upward and pass through the water surface, allowing him to see the sky in a circular bright cone. But rays coming from the steeper angle do not escape the water, they bounce back from the surface, making part of the surface look like a perfect mirror. He wants to understand why light escapes only through a certain angle. And right now he has a table here which gives the incident angle on the water, then the refracted angle in the air, and the diverse observation. So you see here there is a pattern, and the concept that is involved here is none other than the you know total internal reflection. So you need to understand that you are looking at TIR, okay, total internal reflection. So let me just put the total internal reflection, right? So you need to understand what we are doing here, total internal reflection. So this is the concept that we are looking into, TIR. Now TIR says that when the light is going from a denser to rarer medium, above a particular angle, it will not escape the medium, and that particular angle is called as the critical angle. And what happens during a critical angle? During a critical angle, that is a critical angle of incidence, the light will graze on the surface. So when the light is going from inside to out, okay, it will graze on the surface. It will graze on the surface. And when it goes on the surface, okay, when it grazes on the surface and goes, what happens here is that the angle of refraction is technically 90 degree, and this is your critical angle IC, right? Now after understanding the situation, now you look at the table and you can clearly understand when the angle of refraction is 90 degree, that is when I have my IC, right? So that particular critical angle, that particular IC value, the incident angle value, is known as the critical angle, right? Now let's try to answer each question. State what is meant by the critical angle of light traveling from water into air. So the critical angle is the minimum angle, right? It is the minimum angle. So what is required here? It is the minimum angle. I'm not writing the whole thing as it has to be written in the examination, but let me tell you what these things are. Let me try to understand. Let me try to make you understand what these concepts are. It's the minimum angle. Okay, it's a minimum angle of incidence on which the light grazes on the surface when it's going from denser to rarer medium, right? Now this is very important for you to understand that this can only happen when it is going from denser to rare medium. There is no point of TIR and there is no critical angle when the light is going from rarer to denser medium. So that particular thing you need to keep in mind, right? Now going to the next question, let's zoom in a bit. Oh, I have zoomed out, sorry. From the table 1, determine the refractive index of the water. Show your working using the Snell's law. Now, to find the refractive index of the water, I have my Snell's law, and the Snell's law says that sine I by sine R is the refractive index of the second medium by refractive index of the first medium. Now, students, you know that the refractive index of the first medium, it is the air, so it is 1. So your N1 is naturally 1. So they are asking you to find N2, the refractive index of the water. And already I and R. So right now I require any I and R value. So I can take any value from here. I can take any I and R value. So I can take 20 and 42. So I would take 20 and 42. So sine, so no, sorry, this is going backwards, right? My bad. So light is going from denser to rarer medium. So that is technically N1 is what I need to find. N2 is air. N1 is what I need to find. And N2 is air because light is going from water to air. So N2 is 1. So my sine I is equal to, what's my sine I value? For 20. Sine 20 by approximately, you will be getting sine 42 is equal to N2 by N1. So 1 by N1. Now, when you're solving for this, now, when you put the sine value, when you do it in the calculator, with putting the sine 20 value and sine 42 value, you will be getting the answer as approximately 1.56. Okay, you will be getting the value for this approximately as 1.56. Now, honestly, students, this is not the value of water. This is the value of, glass. So here there is a mention that you need to mention something here, that this is not the value of water. 1.33 is the value of water, and that is something you should be knowing. Now, who knows, this question they might have deliberately given this wrong answer. Let's see if there is there anything that we have in the upcoming part which asks this particular thing, which asks about this particular anomaly. Okay, so it might not be water, or it might be some other liquid which has a refractive index of 1.56, but glass has 1.56. Understand that. Explain why at the ray. Now you might think, will you get marks for 1.56? Yes, you will get marks for 1.56 because they are the given value. When you substitute that, that's what you are going to get. Okay, now explain it why at 40 degree reaches the surface but does not leave the water at 50 and 55. Now at 40 degree it grazes on the surface, but 50 and 55 it does not leave the surface because of total internal reflection. You can clearly write down, it is because of TIR, because of the total internal reflection, the light does not leave the surface. It's because of the TIR, it doesn't leave the surface. Leave the surface. Because the theory says, I'm not writing every word, because the theory says, now please do not worry about the typos. I'm very bad at typing. Okay, because the theory says that when angle of incidence, when I is greater than critical angle, no refraction will take place. No refraction will take place. Okay, no refraction take place. Only you have reflection, and that reflection is none other than TIR. Please don't worry about my typo, students. I am just typing it very fast. My main concern is that you should understand the concept. That's all. Typing, you will do it very well in the examination. I know it. Don't worry. Okay. Right, so that's the answer for this particular question, and you should give proper reasoning saying that why it does not cross the boundary after 40. This is the reason. Using the image and the ray diagram model, okay, there is no image here. So explain, this basically table, not the image, the ray diagram model. Explain why the diver sees sky only within a bright cone. which seems like a mirror region outside the cone. Now students, let me tell you one thing why. Let's say that you have this water level, water surface, okay? Now, and let's consider that we have the diver here who's looking on top, okay? You have the diver here and his face is here, is looking on top. And this side, he has a maximum value around, more than which, if the angle of incidence is more than which, he will not be able to see anything outside. And this angle is 40 according to the diagram. And this side also, same. You have an angle of incidence. If your angle of incidence is greater than 40, you will not be able to see anything outside. So the region, if you see this region, this particular region, this particular region is the only place where he will be able to see things outside, because below this region, if the light is below this region, if the light is making angle smaller than that, that is when the light leaves the water. That is where the light leaves the water. So now, so it forms a triangle here. In 2-dimension, forms a triangle. But you think about 3-dimension. You think about 3-dimension, it's a cone, right? You think about 3-dimension, it's a cone, and that person will only be able to see things which are on the circle of the cone, right? The cone has a base, right? So whatever things are on that base, that is what the person will be able to see. So that's why he sees cone. And the things remaining, so anything outside the cone, this region outside the cone, it will be like a mirror. Why? Because the light, for understand students, because the light which is going away more than this angle is going to get reflected. So when it is going to get reflected, that particular portion is going to act like a mirror, and that portion is going to be acting like a mirror. So you need to understand that. That's why the diver sees a cone of light. That is what the question mentions. You need to answer this properly, exactly as required. The next question, the diver moves deeper from 4 meter to 7 meter. Predict whether the size of the visible cone increases, decreases, or stays same, and justify your answer with the physics principle. Now students, looking at the same diagram, you see here, this is 4 meter. He is underwater 4 meter, right? Initially is underwater 4 meter. Now, when he goes to 7 meter, let's say that he goes more down 7 meter, right? And keeping the angle of the cone 40 degree, because that has to say 40 degree, because more than 40 degree it will not appear. So the keeping the angle as 40 degree, let's say that he went down and you keep the angle as 40 degree same, because angle cannot change more than 40 degree. Keeping the angle as 40 degree again in both the side, you can clearly see the cone has become bigger. So the more deeper he goes, he can see a larger area. Interesting phenomenon, right? The more deeper he goes, he's able to see a larger area, because you see here, now when he's here, the circular region now is increased. This is the region now. As you can see here, this is the region now where he will be able to see the whole things outside. So technically, what remains same? The critical angle remains same. But as it keeps going down, the height of the cone keeps increasing and the angle remains the same. Finally, because of that, the whole size of the cone increases and the size of the circular area through which the person can see increases. So this should be your prediction. So this is one of the very beautiful question. uh, yeah, so here I do make a lot of questions for students like you who are IB, MYP and IGCSE and Cambridge students. So I'm making a lot of student questions like this, so that you guys are able to learn more and be more exam prepared. So I'll be coming with more videos of IB, MYP in the upcoming weeks. So my target is to at least solve one question per week for each curriculum wise, so that you are benefited with this. So with that, I'll end my video today. We will see in the next video. Bye students.